Okay, welcome everyone to the second session of PyWhy Causality in Practice. I'm so delighted to have Keith Battocchi with us. Keith is one of the main developers for EconML. And EconML, in fact, is one of the most popular libraries in PyWhy ecosystem. And so we are very glad that Keith has agreed to not only present an introduction to EconML for those who might be new, but also the latest and greatest in the next version of EconML, which is 0.15. So with that, I will hand it over to Keith. Take it on.
Great, thanks. I was mentioning Ahmed just a couple minutes ago. If people have just joined, I threw together some quick slides. We just put out the beta release of our version 0.15 last week, and so I've thrown together a couple slides on some of the new features. That definitely doesn't cover everything that's new. We've had a lot of contributions from the community. We fixed a lot of bugs, but I wanted to cover three big new features. But I guess first, I thought I would just talk a little bit about EconML's position in sort of the causal space. How does EconML fit in with the rest of the projects in PyWhy and things like that? Talk about just a very brief intro to the basics of EconML and what EconML is all about, and then talk about the three big sort of key pillars to our 0.15 release, which are model selection, federation, and validating Kate estimates. Please, at any point, jump in with questions or comments. I'm happy to keep this pretty informal. So, for the first question of where does EconML fit in with the whole causal space, I thought there's a paper, Emre Kidgeman had a good paper on how causal reasoning and LLMs interact. But within that paper, I think there was this great figure, and I've just highlighted in this blue oval, I don't know if people can see my cursor, the estimation part. But really, when it comes to thinking about what is causal inference, what is causal analysis, I think there are lots and lots of different things that fit under that umbrella. And, so we can think about situations where maybe we don't have any idea what causes a disease, for instance. And so we're really curious about what things might cause it. But we have other scenarios, and so we can create a causal graph with different nodes, and maybe we can use some different tools to identify which edges of the graph should be present and which should be absent. But then at some point, once we've identified the graph that we think applies to a situation, we want to often come up with estimates for how strong is the effect of this particular variable on some other variable. Sometimes we're doing that, again, like I said, where we're starting all the way from causal discovery. But in many other cases, people already know beforehand, I'm a policy, I'm a store manager, and I know that if I set the price of my products to something different, people will buy a different amount, right? And so in any case, we know that we have some variable that we either can change or we want to understand how changes in it drive some other variable. And so EconML fits in there in this estimation step. And so we support connections to the other PyWhy libraries like DoWhy. And so, so you can use DoWhy to call into EconML to do estimation. You can use EconML to call back into DoWhy and populate a graph. But in many cases, people are jumping straight into EconML, and they know that they're in a situation where they are the person who can be moving some lever to drive change, and they want to know, should they do that? What would be a good policy? And I can't see any chat, so if people have questions, please feel free to just jump in with them. And so, as I was saying before, the core of EconML is really this estimation setup where we have a known graph, we have a known treatment T, we have a known outcome Y, we have known features X and controls W, The difference between those is very subtle, and I'll try to explain that in a second. And sometimes we have what are called instruments Z, which I'm not going to go into. But if people are familiar with like econometrics, oftentimes economists are really interested in using instrumental variables to produce causal estimates, and we do support that for some of our estimators. And then, the main output of our library is we want to calculate the effect of moving from some treatment T1 to some other treatment T2, conditional on the features X. And so that's the difference between X and W, is that X and W might affect both the treatment and the outcome. But in terms of the effect of moving from one treatment to the other, we're only considering the features X. We're not considering things in the controls W. And so that's really the basics of EconML. Is it's all about this single conditional average treatment effect calculation. And we provide a lot of support for both different estimators, as well as not only calculating the effect, but possibly calculating the marginal effect, calculating not only the effect, but confidence intervals around the effect. And so there's a lot of stuff around it, but really at its core, this is the key thing that EconML does. And then, I just wanted to talk a little bit about, how can we even estimate a causal effect? And really we have two strategies, but they all boil down to logic that comes from a randomized controlled trial. And forgive my terrible drawing, but I think it's interesting to think about why people care so much about randomized controlled trials. And I'm an engineer, not a researcher, not an economist. So this is my take after working in the space for a while. If people have corrections or comments they'd like to make, I'd be happy to hear them. But one of the amazing things about randomized controlled trials is you can basically take your treatment, have some population that doesn't receive it, some other population that does, where you're randomly assigning people to one group or the other. And at the end of the day, what you'll get out is, a histogram of the effect for the people who were treated and for the people who were not treated, right? And incredibly, we can compute this average treatment effect with very, very, very few assumptions, right? All we need to know is that basically the effects on different people, the treatments on one unit do not affect the outcomes on a different unit, and that we're not having any people whose effects are so large that we can't compute an average value or something like that. And so under very, very minimal conditions, we can compute this average treatment effect. There are a lot of other things that you might want to compute that we really can't, right? So you might want to know, like, is everybody better off if they're treated? And that's something that you can only compute if you have a lot of different assumptions, right? Like we might assume, oh, the order of the people, the order of the things in this top histogram and this bottom histogram are the same. For the average treatment effect, you don't need any of those assumptions. You can really compute it under a bunch of under very, very few assumptions. So it's a really useful technique. And then that's a randomized controlled trial for the average treatment effect. You could do a similar thing for the conditional average treatment effect, right? If you're randomizing everybody, then you are also randomizing people under the age of 30. And so again, you could say, okay, conditional on being under the age of 30, what is the effect of moving from one treatment to another? And so our library, again, that's the main thing that we're trying to compute, is something like that, but where instead we have observational data. And so what do we do when we have observational data? We need to somehow find an experiment. And so we have two sort of broad approaches to that. One approach is when you have measured all of the confounders, where a confounder, again, is something that could affect both T and Y, your treatment and your outcome. And so we have a family of estimators called DML for double machine learning. Those apply to situations where the treatment is discrete or continuous. We have another family of estimators called DR learner. That applies when there is a discrete treatment. And then there's a second sort of technique that you can use if you haven't measured all confounders, and so you're worried that maybe there's something that you haven't measured that you can't directly account for, and that's to rely on an instrument. And again, we have a couple of different families of instrumental variables, estimators, DMLIV and DRIV. And I'm not going to go into too much depth on these estimators, but I just wanted to give you a sort of like big picture view of like what are the sorts of things that EconML provides. So we provide a number of different estimators. And I guess, one of the key things, the reason ML is in the name of our library is in order to compute these estimates, basically, often there's a first stage where we're learning what's called nuisance models. And so those are things like we want to be able to predict the treatment from all our features and controls. And so we're going to use flexible machine learning methods to learn those first stage models. They're called nuisances because that's not really what we're after. What we care about is the treatment effect. And so we have to compute these things like the propensity of somebody to receive the treatment, but that's not really what we're after. And we want to be able to use whatever machine learning methods people have come up with. And so, EconML is a Python library. And so we support not only sklearn models, but any other model that sort of fits that predict paradigm. We support a common API for many different Kate estimators. So, I talked about DML versus DR learner versus DMLIV. All of those estimators, some the IV estimators require you to pass in an instrument, but the API for all of them looks extremely similar to each other and also similar to sklearn. So instead of fit and predict, we have fit and effect, or marginal effect, or const marginal effect. So we have a number of different methods for getting the effect out in different forms, but we tried to hew as closely to sklearn as we could. And so, hopefully the interface is familiar to users who are data scientists or familiar with running different sorts of machine learning methods. So that's like the big picture philosophy. That's where we fit into the larger causal inference space. And I think, many people are using EconML. I think, we're very happy with it as a library, but we have certainly had people who have run into certain problems pretty frequently. One thing that has happened a lot is that these first stage models do actually matter. And so, for DR learner, it's called DR learner because it's doubly robust. And so if either your treatment model or your outcome model converges to the true treatment, propensity or the true outcome, then your treatment effect estimate will also converge to the true treatment effect. But if you use bad first stage models, then you're going to get a bad result. And so when we were building the library, our assumption was, the people who were using it were going to be data scientists, and they would be choosing first stage models that were really appropriate for their scenario. In practice, a lot of times people have just left them to the default, which is a very natural thing. When I'm testing out a library, I leave things set to the default as well. And our defaults, we don't know what people's data looks like. And so our defaults have been, simple, fast to fit things like linear regression. And so, one of the new features of the 0.15 release is model selection. And so now you don't have to specify a single model for your treatment model, your outcome model. We will now let you either pass in a list, or you can pass in something that will do cross-validation, either an sklearn, grid search, or random search, or lasso CV, or one of the other linear estimators that uses CV internally. And so, first of all, users can now pass in a set of models to use for their first stage models, and we will select the best one. Another reason, I think one reason maybe people haven't done this is it's a little bit complicated to do this, even if you wanted to do the model selection yourself and then pass in the best model you found. A lot of our methods end up taking the input data and doing some simple pre-processing. And so it's not always obvious exactly what you should yourself, if you wanted to do this yourself, what should you be fitting your Model T on, for instance, to in order to do the model selection yourself. Inside DML, for instance, we are concatenating X and W. And so you would need to make sure to do that yourself. Now you don't have to worry about that. You pass in either a list of models or a model selection object, and then we will do all that model selection for you, and then use the best model when it comes to, we will select the best model and then do our cross-fitting procedure using the best model. And so that will hopefully result in, first of all, a lot better behavior out of the box, but it also gives users more power to, if you were picking a random forest regressor, but you sort of hard-coded the parameters, well, now you can pretty easily do a hyperparameter search over that and include that in there. And for illustration purposes, I've put LinearDML here, but we support this now for all of our ortho learners. So that's one new feature that we're really excited about. A second new feature that we're really excited about is model federation. And this one's a lot more limited, which I'll try to talk about at the end. But the big idea here is all of our estimators work on in-memory data. And for various reasons, it's not always practical to fit all data into memory on one machine. So one of those, one obvious example is you just have too much data, right? You're in some sort of big data scenario where you just have too many rows, it's not all going to fit. But increasingly, we're seeing policy scenarios where maybe you have data from different geographies, and there are, say, privacy regulations in Europe that are different than privacy regulations in the US. And so you really can't take all your data, move it to a single place, and fit a model on it. And so one of the new features in our 0.15 release is support for federated models. And so now what you can do is you can fit models on different subsets of the data, and then you can say, like, pickle them, unpickle them in a single place where you can then create this federated estimator object that we support. And then, in order to do that, you don't have to send all the data to the central location. You just need to have the fitted models that get sent to the central location. And then we will create this federated estimator that will use the fitted models from all the different sections and bring them together into a single model that hopefully has, estimates that include, that are improved by having access to all the different data. In order to support this, there's some sort of math behind it that shows how to do the calculations we need to do for the final model in the case of linear final models. So that's things like LinearDR learner, LinearDML, but we do not support this for all models at the moment. I think it's something that we're looking at in terms of how to support this for other models, but at the moment, we only support it for linear final models. I would say most people that we talk to are using things like either LinearDML or LinearDR learner. So we hope that this will cover most scenarios. But if you have another scenario, we would love to hear about what that is and what pain points you might be having. And then our final new feature that we're really excited about is a feature around Kate validation. So, a lot of times we are fitting these Kate models. Again, Kate is the conditional average treatment effect. And it's not always easy to know what variables should I include in X. If I'm fitting a Kate model, okay, I'm getting a prediction out for different X's. Would I have been better off just fitting an average treatment effect model? Or, is the variation that I'm seeing in my predictions conditional on different subsets of X real, or is that just an artifact of noise? And so the solution that we've created there, some of Vasilis Serganis's students at Stanford contributed this feature, which is a new class called R-Tester. and that has a bunch of different methods to test things like calibration and other metrics that will let you know, are you gaining anything by fitting a Kate instead of just an 8? And so below, I've plotted one of the sorts of charts. There's a sample notebook that uses the class that shows you how to use it. But here it's showing you sort of the group average treatment effect for a bunch of different points. And the idea here is that if your model is, if your Kate really is different than your 8, then it should be the case that if you group together the groups for which you see different Kates, then when you use that as a sort of way to stratify them, you should see this linearly increasing plot like you do in this example below. And so this is a case where if you see an outcome like this, then for this treatment, it really was worth fitting a Kate instead of an 8. And so again, it's something that is new to the library. I think this is one where, the API may change over the next several releases as people start to use it more and we get feedback. But I think we're always interested in ways to help people understand whether their models are good. And I think this is a really valuable technique. And so that's really it in terms of my intro to the new features. Again, I'm happy to take questions or other feedback. I think, as I mentioned, there are a bunch of new features that didn't fall into these 3 main pillars for this release. So I know that, for instance, Fabio added some fixes for being able to support missing data. I think we have a new feature, which is that if you are using Ray, then you can use Ray to parallelize the fitting of nuisance models, which speeds things up nicely. So there are a bunch of other little features as well. But we did put out the beta last week, and we would really love it if people could try it out and let us know what you think. Let us know if there are things that are missing. Let us know if you run into any issues. And yeah, that's really all I had today. But again, I'm happy to answer any questions people might have.
Thank you so much, Keith. This was quite useful for us to know, I think, all the latest methods, especially the validation ones as well. Cool. So we have lots of time, actually. So any questions or feedback for Keith? We can start now.
Hi, Kid. I have a question about model selection.
Yeah.
So you mentioned like given a list of methods and then like the new EconML will suggest the best ones. So what happened like in the case of trade-off like methods, like in some sense this method is better, but in the other sense, like what you're gonna do with that?
So the way I guess it depends on what you mean by in one set versus another, but the way that the functionality works now is that we will take all of the data that you pass in, and then we'll use cross-validation to check each method where we're splitting the data into folds, fitting each method on all of the folds, and then computing the out-of-sample score for each method, and then picking the one with the best average score. And then we're doing our cross-fitting where we again split the data and then use that best method on each split. And so it's definitely the case that, when we do that first cross-validation, it could be the case that, on fold one method was better, but on fold 2, a different method was better. We're just going to take the average of all of those scores and see which was the best overall. But if it's the case that when we're randomly splitting data, your methods are very close in performance, then we would expect that you're not gonna end up doing dramatically worse than you would even picking different methods for the different folds when we do our or cross-fitting. Having said that, I think the functionality right now is a little bit underdocumented, but one thing that you can do, but that we will make it easier to do before our final 0.15 release, is make it so that if you want to, you can also do model selection inside of cross-fitting, so that instead of picking a model at the beginning and then using that for the cross-fitting part, when we split into folds for the cross-fitting, we'll let you pick the best model within each one of those. And so there's a sort of hacky way to do that now, but we will make that easier as part of our final release as well. But in general, I would not expect that to be necessary.
All right, thank you.
You're welcome. Thanks for the question.
Hey, Keith, I have a question about the last methods that you mentioned, the validation methods.
Sure.
So if people want to read up more about the methods that are implemented, is there a list of references or papers somewhere or you can share?
Vasilis is probably the best person who appears to be on the call, is probably the best person to talk about references.
I'll send you, I'll post here a notebook that was the originator of the methods that, oh, this one, yes.
Okay.
So this is what the students used to then translate into production code, and that contains, I think, some references.
Yeah, so I put the link to our documentation, but that's, I think Vasilis is talking about a different notebook that has references. So.
Oh, okay.
So the one I put is, if you want to see how to use our tester class with our library, that's what to look at, but it does not include references. So
sure. Okay. Well, let me post the things.
I think, yeah.
Got it. Yeah, thank you. Yeah, one reason I'm asking also is that if there are any other links, Keith, that you would like people to check out after your talk, feel free to share them here, and I can include that in the recorded presentation as well.
Great. Yeah, I'll include a link to our documentation on the federated estimation as well. So Emma, right now, oh, yeah, sorry.
From Emily.
Yeah, now that I've stopped sharing my screen, I can see the chat. So
sure.
So right now we don't have any specific integration with Causal, but that's something that I think we'd like to look at going forward. Right now, this is, I think Causal to some extent is also interested in selecting between methods, whereas this is really about, for any given estimator, what sort of first stage models would you want to have? But I think it is something that we'll look at more closely in the future. And it looks like Vasilis has included the lecture notes that have references to those validation metrics.
Okay, thanks. I may also just switch gears and ask a more general question. So if people are looking at this talk and interested in contributing to EconML, how do they do that? Do they have to reach out to you, or is there a more easier process?
I mean, definitely don't reach out to me personally. I think, we're happy to take contributions. Some of the Ray feature for parallelizing the fitting of first stage models, for instance, was something that was not on our radar at all. And somebody submitted a PR and it looked good. And so we got them merged in. I think, reaching out by filing an issue describing what you're proposing would be a great thing. You know, so I think it depends a little bit, right? If there's something that you are happy to work on and that you think would be a good fit, but that you haven't implemented yet, then I think reaching out in the form of an issue on our GitHub repo would be a great way to do that. And then we can sort of hash out any details of, you know, if there are philosophical reasons we might want to do things differently than how you're expecting that you would want to do it. We can get those sorted out beforehand. You know, I think what we want to avoid is having a PR that's, you know, basically done, but that's something that comes to us from our perspective out of the blue that doesn't clearly fit in with how we might want to do things, or, you know, future things that are coming to our roadmap or something like that. But in general, I think we're very happy to take PRs, and the, you know, key things there would be trying to keep the implementation as easy to review as possible. You know, that means smaller features are going to be easier to review than big features. I think, you know, if it's something, the model selection work, for instance, ended up touching a lot of different classes. And so that's the sort of thing that's probably easier for us to do internally. And so if it's, you know, a feature that will help people, then we're happy to work on it. But that might be easier for us to do than to have a PR coming from somebody else that touches, you know, a couple dozen files. But again, it does sort of depend. If it's a really valuable feature, if there are tests that come with the PR that clearly show that the feature works and that nothing existing has been broken, then, you know, I think we're not opposed to even large PRs, but I think talking about it first helps us figure out how to slot that in and schedule time for reviews and things like that.
Awesome. Any other questions? If not, I'd like to thank Keith again. Thank you so much, Keith, and I'm looking forward to using the 0.15 version from now on.
Please do, and please, you know, seriously, any feedback anybody has on either, you know, places where the new features work well or places where the API design could be tweaked, happy to hear about it.
All right. Thank you, everyone. We'll be back with our next version. Look out for updates on Discord. Bye-bye.
Thanks. Bye.
Thanks.